Hi ladies, this is after lesson 4.4 but before lesson 4.5. This is just meant to be some review for simplifying, adding and subtracting radicals. And then we'll also do in this video later a section about multiplying radicals. So on your note sheet, you have perfect squares listed. So perfect squares are like 1, 4, 9, 16. Where you can take the square root of that number and get a number, like an integer. A square root, when you have a square root, you always have plus or minus. Okay, so for example, the square root of a squared is plus or minus a, because it could be a times a equals a squared, but also negative a times negative a equals a squared. So always make sure when you're taking square roots you have plus or minus. This is the radical symbol, and the radicand is the number inside the radical. So for example, the square root of 50. 50 is the radicand. All right, so let's get into simplifying some of these radicals. So remember, when you multiply radicals, the square root of a times b is the same as the square root of a times the square root of b. So for example, the square root of 50 is the same as the square root of 25 and the square root of 2. What's the square root of 25? It's a perfect square. Square root of 25 is plus or minus 5. So you have plus or minus 5 times the square root of 2. So this is the same as the square root of 50. Okay, so that's the square root of a times the square root of b is the same as the square root of ab. All right, so let's look at a couple of these examples on your note sheet. Steps for simplifying: find the biggest perfect square. So find the biggest perfect square that divides into the radicand. So that's find the largest perfect square that is a factor of the radicand. And then simplify the perfect square, plus or minus, and then keep the leftovers under a radical. So let's look at the first one. Simplify the square root of 16. So the square root of 16 is the same, or sorry, the square root of 160. The square root of 160 is the same as the square root of 16 times the square root of 10. 16 is the largest perfect square that divides into 160. So the square root of 16 is plus or minus 4 times the square root of 10. Now, the square root of 10 cannot simplify anymore. There are no perfect squares that divide into 10. So that's our final answer, 4 times the square root of 10. Let's look at the next one. What's our largest perfect square? So you might think 15 and 10 right away, but 15 and 10, neither of those are perfect squares. So try to find the largest perfect square. If you can't find the largest perfect square, then factor. So 15 and 10, 5 and 3, 5 and 2. So the largest perfect square then is 25. So that's 25 times 3 times 2, or 25 times 6. Okay, so if you can't see the perfect square right away, then go ahead and factor, and then find the perfect square that way. So the square root of 150 is the square root of 25 times the square root of 6. Square root of 25 is plus or minus 5. Plus or minus 5 times the square root of 6. All right, then this next example, negative 24. So we're going to keep that negative sign there. What's the biggest perfect square we can find for 24? We have the square root of 4 and 6. So negative square root of 4 times the square root of 6. Now this one's a little bit, it can get a little bit confusing, but you just have to pay attention to your taking the square root. So remember the square root is positive or negative. So that's negative plus or minus 2, because the square root of 4 is plus or minus 2, times the square root of 6, which we cannot simplify. So negative 2, so negative positive 2 is negative 2, negative negative 2 is positive 2. So that is still plus or minus 2 times the square root of 6. So yes, you have a negative here, but you also have still plus or minus 2. And so here's your final answer. 2 plus or minus 2 times the square root of 6. All right, now these next ones have a coefficient outside of the radical. We're going to keep that there, just like we kept the negative sign there in the last problem. So we've got 2, we want to find the largest perfect square, which is 100. So 2 times the square root of 100 times the square root of 5. So that's 2 times plus or minus 10 times the square root of 5. What's 2 times positive 10? So it's either 20 times the square root of 5 or 2 times negative 10, which is negative 20 times the square root of 5. So we still have plus or minus 20 times the square root of 5. Anytime you're dealing with simplifying radicals, you're going to have 2 answers. Anytime you take the square root of anything, you're going to have 2 answers. All right, so the next one, simplifying negative 3. We're going to leave that there, times the square root of 54. So again, we're looking for the largest perfect square. So that's times the square root of 9 times the square root of 6. So that's negative 3 times plus or minus 3 times the square root of 6. The square root of 9 is plus or minus 3. So that gives us plus or minus 9 times the square root of 6, because negative 3 times positive 3 is a negative 9. Negative 3 times a negative 3 is a positive 9. So we still have plus or minus 9 times the square root of 6. All right, the next part is about adding and subtracting radicals. So once we know how to simplify, we can then add or subtract. Just like when you're adding or subtracting fractions, you want it to be in the simplest form so that you can actually, or you want a common denominator so you can actually add or subtract them, and then you'll simplify. So when we're adding or subtracting radicals, we can only add terms that have like radicands. So again, radicand is the number inside the radical symbol. So think of your radical as like a variable. So you can add x plus x, and you get 2x. But you cannot add x plus y. That's just x plus y. That's as simple as you can put it. So if you think of your radicals as variables, just the same kind of rules apply. They have to be like terms. So in this case, we need like radicands in order to add or subtract. So let's look at both of these. We might have to simplify the radicals first before we can add or subtract. But we are looking for common radicands, and those are the only ones we can combine. So 3 times the square root of 6 and negative 4 times the square root of 6, we can combine these because they have like radicands. And we end up with the negative square root of 6. This 3 minus 4 is negative 1. All right, look looking at the next one, example 7, we've got 2 times the square root of 15 and negative 6 times the square root of 15. So we can combine these two, but this other one, this is by itself. We can't do anything with that because, first of all, we can't simplify the square root of 15. That's in its simplest form already. But it cannot be combined with anything that has the square root of 3. So we're going to take 2 times the square root of 15 minus 6 times the square root of 15, and we get negative 4 times the square root of 15 plus 3 times the square root of 3. And that's it. That's as far as we can go. All right, if you look at the next ones, we have to simplify first. So right now, these radicands are not similar, or they're not the same, but they do have similar terms. So the square root of 12 is the same as the square root of 4 times the square root of 3. So we can simplify 3 times the square root of 12 as 3 times the square root of 4 times the square root of 3. And that's plus 4 times the square root of 3. So that term doesn't change, that stays the same. All right, now if we take the square root of 4, we end up with 3 plus or minus 2 times the square root of 3. Plus 4 times the square root of 3, which again, that doesn't change from the last step. All right, now 3 times plus or minus 2. That is plus or minus 6 times the square root of 3 plus 4 times the square root of 3. Again, that does not change. It's the same as last step. So now you have to think a little bit. When you simplify radicals, you will always get 2 answers. And then if you have plus or minus 6 times the square root of 3 and you're adding 4, you want to add 4 times the square root of 3 plus 6 times the square root of 3 and 4 times the square root of 3 minus 6 times the square root of 3. Okay, so we're going to have 2 answers. So if we look at the positive one, positive 6 plus positive 4, we end up with 10 times the square root of 3. Or if we look at the negative 6 times the square root of 3 plus 4, we have negative 2 times the square root of 3. So we still have 2 answers, just like we've always had 2 answers, but now they just look a little bit different. So again, anytime you're simplifying radicals, you will have 2 answers. All right, let's look at example 9. For example 9, we have negative square root of 27, which is the same as the square root of 9 times the square root of 3, plus 4 times the square root of 48, which is the same as the square root of 16 times the square root of 3. So we're trying to get like radicands. Okay, so we're trying to find, for 48, we're trying to find another one that could have a perfect square and square root of 3 in order to combine these. All right, so negative square root of 9, just plus or minus 3 times the square root of 3, plus 4 times the square root of 16, just plus or minus 4 times the square root of 3. All right, so now since we've simplified 2 radicals, we're actually going to end up with 4 answers because we have plus or minus 3 times the square root of 3 and plus or minus 4 times 4 times the square root of 3. All right, so if we simplify this a little bit more, we got plus or minus 3 times the square root of 3 plus or minus 4 times 4, 16 times the square root of 3. All right, so this is a little bit more complicated, but you've got 2 answers for the first simplified radical and 2 answers for the second simplified radical. So let's say we do plus 3 times the square root of 3 plus 16 times the square root of 3. We end up with 19 times the square root of 3. Now if we did both minus 3 times the square root of 3 and minus 16 times the square root of 3, we end up with the same thing, and it's negative 19 times the square root of 3. So we've got plus or minus 19 times the square root of 3. Now let's look at if the first one was negative and the second one was positive. So negative 3 times the square root of 3 plus 16, we get 13 times the square root of 3. Now let's look at if this first one was positive and the second one was negative. So that's 3 times the square root of 3 minus 16 times the square root of 3, which is negative 13. So we still have 2 answers for each simplified radical, so we end up with 4 answers. But it's plus or minus 19 times the square root of 3, plus or minus 13 times the square root of 3. All right, so that's our adding and subtracting. Now let's look at the multiplying and dividing part. So this is on the back side of your note sheet, your review sheet. And so right now we're, again, the square root of A times the square root of B is the square root of AB. So we're going to use that here. And if we can simplify it, we'll simplify, but if we can't, then we're just going to leave it. All right, so what's 6 times 7? That's 42. So the square root of 6 times the square root of 7 is the square root of 42. That's as simple as it gets. We can't simplify that any further. There are no perfect squares. For the second one, we've got the square root of 6 times 7, which is just 7 times the square root of 6. And for the last one, we've got the square root of 7 times the square root of 7, which is the square root of 49, which is plus or minus 7. So don't forget that when you simplify radicals, you have plus or minus. All right, now the next step is to use the distributive property with radicals. So when we use the distributive property, again, we multiply each term inside the parentheses by the term on the outside of the parentheses. So you've got square root of 6 times square root of 7, which is the square root of 42, plus 5 times the square root of 6. Again, neither of those can be simplified, so that's as simple as we can go, so we're going to leave it like that. And then the next one, square root of 6 times the square root of 7 is the square root of 42. Square root of 6 times the square root of 12 is the square root of 72. Now, for this one, 72 we can simplify. So that's the square root of 42 minus the square root of 36 times the square root of 2. 36 is the largest perfect square we can find in 72. And then the leftovers are 2. So we've got square root of 42 plus or minus 6 times the square root of 2. Because when we simplify radicals, we've got 2 answers, a plus and a minus. And that's as simple as we can go for this example. In order to multiply 2 binomials, we need to distribute. Or use void. All right, so again, remember we can only add terms with like radicands. So square root of 6 times the square root of 7 is the square root of 42. Square root of 6 times negative 5 is negative 5 times the square root of 6. Square root of 7 times the square root of 7. And then 7 times negative 5. Alright, so here, that's as simple as we can go. We can't simplify square root of 42, square root of 6, or the square root of 7 to get like radicands. So that's it for that one. That's as simple as we can go. Looking at example 4, we're going to do the same thing. We're going to distribute. This is one term. This is another term. So 2 times the square root of 6 times 3 times the square root of 7 is 6 times the square root of 42. 2 times the square root of 6 minus times negative square root of 5. Again, we multiply the radicals together. So you've got minus 2 times the square root of 30. 7 times 3 times the square root of 7 is 21 times the square root of 7. And then lastly, 7 times negative square root of 5 is minus 7 times the square root of 5. None of these radicals, we can't simplify any of them, so that's it. We can't add any. None of them are like radicands. So that's as simple as we can go. But for this next one, square root of 6 plus 7 squared is the same as square root of 6 plus square root of 7 times the square root of 6 plus the square root of 7. And remember that a plus b squared equals a squared plus 2ab plus b squared. So this is a shortcut that we looked at in lesson 4.3, I think it was, maybe 4.2. So we can use that rule here. So a squared, which is our 6 square root of 6 squared, is the square root of 36. 2ab plus 2 times the square root of 6 times the square root of 7 plus b squared, which is the square root of 49. All right, so square root of 36 is plus or minus 6 plus 2 times the square root of 42 plus or minus 7. All right, so we have a couple answers here for this problem. So we've got plus or minus 6, plus or minus 7. We can combine these terms. Plus 2 times the square root of 42. So 6 plus 7 is 13. Plus 2 times the square root of 42. Negative 6 minus 7 is negative 13. So plus or minus 13 plus 2 times the square root of 42. Or we could have negative 6 plus 7, which is 1 plus 2 times the square root of 42. Or we could have positive 6 minus 7, which is negative 1. So plus or minus 1 plus 2 times the square root of 42. So again, since we simplified the 2 radicals, we're going to have 2 answers for each of them, which gives us a total of 4 answers. So don't forget the plus or minus when you're simplifying radicals. All right, remember that a minus b times a plus b is a squared minus b squared. I think we used this a little bit earlier, but we're going to look at it again. So a squared minus b squared is the same as a minus b times b plus b. So here's a plus b. Here's a minus b. So we can use that a squared minus b squared. So that's the square root of 36. A squared is 36 minus 49. The square root of 36 is plus or minus 6 minus 49. So positive 6 minus 49 is negative 43. Negative 6 minus 49 is negative 55. So we have two answers, but we have to think about it a little bit. It's not just plus or minus. And then here, again, example 7, we've got a plus b times a minus b. So we have a squared minus b squared. Okay, so our a squared is 3 times the square root of 6. And our b squared is the square root of 3 squared. Alright, so 3 times the square root of 6 is 3 squared, and the square root of 6 squared, minus square root of 3 squared. Okay, so 3 squared is 9. Square root of 6 squared is plus or minus 6. So 9 times, actually should be multiplied, 9 times plus or minus 6 minus plus or minus 3. Okay, so this should be plus or minus 56 plus or minus 3. So again, positive, we're going to, since we simplified 2 radicals, we're going to have 2 solutions for each simplified radical, which gives us a total of 4 solutions. So 56 plus 3 is 59. Negative 56 minus 3 is negative 59. So plus or minus 59. And then negative 56 plus 3 is negative 53. Positive 56 minus 3 is positive 53. So our answer, plus or minus 59 or plus or minus 53. All right, that's it for our review for simplifying radicals so far. We do have to go through a little bit of division, but we'll do that in another class. So please jot down any notes you have. If you need extra review sheets, please see me, and we'll go over those questions. Thank you.